If there is any confusion for anyone on any topic, we can discuss that. यथार्थ आया ना? आया, चलो आगे. So first page we have nothing to discuss. Okay, the whole periodic table is divided into metals, non-metals, and there are certain metalloids. I hope you know what are metalloids. Metalloids are which have properties of metal as well as non-metal, like silicon, germanium. Metalloids play a vast role in the semiconductor industry. Everything that you see on the left are metals. Everything that you see on the right are non-metals. Now there are only two elements which exist in liquid in normal temperature. One is being attributed to the metal family. One is attributed to the non-metal family. Iodine is the only metal which is liquid. Mercury is the only metal which is liquid at room temperature. I'm sorry. And bromine is the only metal which is non-metal which is liquid at room temperature. Okay? So although we will study later on, but let's have some quick ideas. Metals always form cations. Metals are the ones who will be losing electrons, and that is one of the characteristic signature of metals, because when you talk about something like a potassium or a calcium, I cannot take calcium and break the bones of Angad, right? You cannot make calcium into a rod, but you can make tungsten into a rod and then can hit and break his bones. That is allowed. But so how do you classify things like potassium, sodium, calcium, magnesium as metals? They all have electropositive valency. Means given a chance, they will be losing their electrons in order to obtain the nearest octet of the nearest inert gas. And it's like this. Like say we have got sodium. Sodium cannot become argon, but it can become the good boy of the previous colony, that is neon. Okay, sodium cannot become argon, because if sodium wants to become argon, he needs 7 electrons, and nobody is that kind enough to give you 7 electrons. So sodium loses its outermost electron and becomes the good boy of the previous colony, which is neon. However, if you look at non-metals, they become the good boys of their colony itself. Now, if you look at somebody like chlorine, chlorine will become argon. Then oxygen will not become argon, means will have the electronic configuration of argon. So this is understood, okay? And so let's talk about some 2, 3, 4 major properties that distinguish metal and non-metal. Number 1, malleability. ये सब repetition हो रहा आता है ना? Malleability is the property by which a substance can be hammered or beaten into thin sheets. Metals must show malleability. However, exceptions will always be group 1. Halina, all this. They are not malleable. So they're alkali metal family, alkali earth metal family. When you talk about metals, always keep in mind, if you want to have the tung metal effect, then you're talking typically of the D block of elements. When periodic table, it's the D block. So metals are malleable. Malleability is the property by which something can be beaten into thin sheets. Like gold, you can make a thin sheet of it. Silver, you can make a thin sheet of it. And then comes another property called ductility. Ductility is the property by which a metal can be, or a substance can be drawn into thin wires. Thin wires, okay? Drawing is an operation. Do you know how drawn into thin wires means? There will be 2 rollers, and you will put a big cylinder of that metal. The roller will squeeze and take out that wire. One side you will pull it, draw out. Ductility does not mean that you melt it and then push it through one shower head spinner and you get some noodles like wire and then cool it. Ductility means you should be able to draw out. That's a way. And right now you might be thinking, kuch cheeze kitna important ho jata hai. You might be just memorizing a definition called ductility, property which a metal can be drawn into thin wires. Just look about that operation, drawn out. Have you done that dirty act of chewing a chewing gum and trying to draw out the chewing gum? Yeah, we used to do. We were garibs now, so we did with chewing gum. You do with mozzarella pizza. And you get all those threads out. So those threads out should have the tensile factor remaining in that. Otherwise, you can't draw it out. Metals have that. हंसी की बात ये नहीं, हंसी की बात ये है कि उस मेटल में वो प्रॉपर्टी होना चाहिए कि जितना आप ड्रॉ कर रहे हो ना, वो आपको ड्रॉ करने देता है. समझ में आया? Okay. Our next thing is about thermal conductivity. Thermal conductivity is the property by which you conduct heat. Metals will always show thermal conductivity. Means if you heat a metal, then it will start getting heated by the property of conduction. Okay? And conduction also happens. Why? Conduction happens due to the presence of free electrons. After all, free electrons are the ones which will help the heat to travel from one zone to another. And the fourth property is electrical conductivity. These are 4 striking differences between metals and non-metals. However, exceptions are there. When you talk about electrical conductivity, you land up with someone called carbon in the form of graphite, which also conducts. Question arises, carbon in the form of graphite, why do you conduct? Because in the form of graphite, my structure is hexagonal. Hexagonal means me as a carbon, I am bonded with 3 other carbon, and the one is, yeah, pi bond. Well, we can't say pi bond in grade 10. Very good, you remember. So we have got a hexagonal structure on top, we have got a hexagonal structure right on the bottom, and between the 4th electron there is a weak bond created out here. So the 4th electron becomes sort of a delocalized electron, contributes to the sea of electrons, contributes to the cloud of electrons. And once the d-electron, see, if you want to conduct, you have to have a charge carrier. Liquids conduct because they have got ions. Solids conduct because they have got free electrons in them. Unless and until you have got free electrons, you will not conduct. Question arises, diamond conducts heat, does not conduct electricity. Diamond's heat conduction is not due to free electrons. There is something called lattice structure, जो आप बाद में पढ़ेंगे. You will not understand it now. But in the case of diamond, it is tetrahedral. Each carbon is linked with 4. So you do not 4, and all 4 are sigma bonds actually, head-on overlap. Okay, so you do not get any free electron. Once you get a free electron, then only there will be conduction. Metals have a characteristic signature of having free electrons in them. Non-metals do not have free electrons, with the exception of carbon in the form of graphite. ये clear हुआ है? अच्छा.
Sir, does it conduct in solid state or liquid?
Which one?
Graphite.
Graphite in solid state.
Okay.
Take your pencil lid and put it in. Never do that. Graphite is actually a very nice powder also. It will conduct. Is this clear? Okay. Some more things we will talk about. Let's say talk about hardness. When we talk about hardness, metals are supposed to be more hard. Again, exceptions are group 1 and group 2. In group 1, you should know what? Lithium, sodium, potassium, because all you are worried about is 0 to 20, and on that side magnesium and calcium. So these are not hard. These do not have tensile strength. These do not have lithium also. These do not have luster. They do not show any sort of brilliance or luster, which is a characteristic signature of all metals. Like gold, silver, they will show luster, which is the best conductor of electricity. Silver is the best conductor of electricity. और यहाँ पे कुछ है? No, we do not see anything great out on this page. So similar thing is talking about using PVC. PVC, you should remember that PVC is polyvinyl chloride. Polyvinyl carbonates are also there. Polycarbonates and polyvinyl chloride. The gray pipe which you see for wirings, have you seen the electrical gray pipes? Those are PVC pipes. PVCs are always straight chain polymer, cross-linked polymer. They are cross-linked polymer, so they have got more hardness in them, thermosetting. And these white ones which you use for making, these are called polycarbonates. They are काफी strong and durable होते हैं, corrosion नहीं रहता है, and very very सस्ता. So we use them, but they will never conduct electricity. That's one of the reasons they are also used as insulators. Plug bodies and other things. The bodies of plug tops and others are made from PVCs and polycarbonates. Clear? Now we talk about non-metal. So in non-metal, carbon-rich compounds to dekh liya. Let's see about non-metals. Iodine is a non-metal, but it is lustrous. These are exceptions, which you should remember. 1 mark question पूछ देगा आपको. So we'll see. Okay. Gallium and cesium have very low melting point. These two metals will melt if you even keep on the hand, but they are not to be treated as liquid. Gallium and cesium, once kept on palm, conduct your body temperature and then they melt. Wherever at room temperature, mercury will always be liquid. Okay.
Not considered liquid because like the room temperature they take.
So the room temperature depends. Na? See, all the studies, if you see Cambridge students and their books, their room temperature is all as per Britain. 25 degree. India में 25 कहाँ रहता है? But we are tropical countries. But even in tropical countries in lab, when you say room temperature, everything is now air conditioned. And the air conditioned comfort is always 22 degree dry bulb temperature and 55% relative humidity. So every room is at 22 and 55. However, Kyoto Protocol tells you to maintain at 24. But आप OT जाएंगे, operation theater, hospital, they're all at 22. 22 में वो melt नहीं करेगा. लेकिन mercury melt करता रहेगा. That's why mercury is used in a thermometer. Clear? Okay. Then let's talk about that magnesium and magnesium ribbon. So what all concepts we have out there? Magnesium is available in the lab in the form of magnesium ribbon. which is always to be scraped before it undergoes for any sort of combustion test. The reason is magnesium forms a hard oxide layer on it. So you scrape it to actually expose the magnesium. And magnesium is very reactive. The moment you scrape it, immediately if you don't burn it, it will again form oxide. And magnesium burns with a brilliant or dazzling white light. Remember the word brilliant or dazzling white light. All the pencils that you burn on Diwali are actually magnesium. They have magnesium. So uska महंगा ज़्यादा होता है वो. Flower pots are also costly because of that brilliant light. सबसे सस्ता होता है वो bomb. ढापटूप फटता है. उसमें कुछ नहीं है. Okay. Alkali metal. Alkali metal means group 1. Alkali earth metal means group 2. They will all be soft. They will not have luster. So I think this part is also. Give an example. Okay, let's try some questions. Give an example of a metal which is liquid at room temperature. Can be easily cut with a knife. Sodium, yes. Don't write Amul butter. Huh? Is the best conductor of heat. Silver. Is a poor conductor of heat. Give the example of a metal who is a poor conductor of heat. Lead. Lead is a poor conductor of heat. That's why lead is always used for. ये देखो ये थोड़ा पेचीदा question था. Lead is always used. Two things. Lead can absorb all sorts of radioactive emissions also. That's why radioactive elements are kept inside lead boxes. ठीक है? Next, a metal which is a poor conductor of heat. Okay, we have done. Explain the meanings of the word malleable and ductile. I think you know what are malleable and what are ductile. Any doubts so far? Which one? It will conduct. It's metal means you will conduct. Whether you're a good conductor or bad conductor, that is different. Bad conductor also conducts. Something that does not conduct is called an insulator. An insulator is an item which does not have free electrons at all. Bad conductor means lead will not be my choice when I want to make wires. Got it? Iron is not my choice. You don't get iron flexible wires. The wires that we buy in electrical shops are either copper or aluminum. Aluminum सस्ता होता है, copper महंगा होता है. बस इतना ही फर्क है. Shall we? Chemical properties of metals. चलें आगे. चलिए. Weber wall, okay?
Yeah, sir, can you go back to the previous activity?
Yeah, previous.
Activity
3.8. Yeah, tell me.
Sir, over
Which activity?
3.8. In front.
3.8 we have not come, I think, still now. This one, yeah. Okay, I'll read it and you tell me where you have a problem. Take a magnesium ribbon and some sulfur powder. Okay. Burn the magnesium ribbon, collect the ashes formed and dissolve them in water. Collect the ashes formed. The ashes are what? Magnesium oxide. You're dissolving magnesium oxide in water. So what do you expect? Magnesium hydroxide. Okay. Test the resultant solution with both red and blue litmus paper. So red litmus paper will become blue. Red litmus because it is basic now. Magnesium hydroxide is milk of magnesia. Okay. Magnesium oxide dissolved in water has become magnesium hydroxide now. MgOH2. Further, is the product formed on burning magnesium acidic or basic? Okay, let's go. Remember one thing. Metals always react with oxygen to form metal oxides, and metal oxides will react with water to form something called a base. And if this base dissolves in water, we call it alkali. And in grade 10, anything which is referred to either a base is actually an alkali. You are dealing only alkalis in grade 10. Clear? If you have a non-metal and you react it with oxide, it forms a non-metal oxide. And this non-metal oxide can either be acidic or can also be neutral. Water is a neutral non-metal oxide, H2O. Okay, na? Acidic means if you react it with oxygen, it will form, react it with water. If you react it with, water, it will actually form an acid. Best example, SOx, oxides of sulfur, COX, oxides of carbon, NOx, oxides of nitrogen. React with water to form sulfuric, sulfurous acid, nitric, nitrous acid, and can also form carbonic acid. Let's go further on this. It says, now burn the sulfur powder. So if you burn sulfur, what will happen? यही वाला कहानी उसमें घुसा हुआ है. So it will become SO2. Place a test tube on the burning sulfur to collect the fumes formed. So you have collected the fumes. Add some water to the test tube. So it has turned to either sulfuric or sulfurous acid. ठीक है ना? Test this solution with blue and lead litmus.
Yeah, but how do we know when it turns sulfurous?
No, that you will immediately, because Physically, if you're doing this test, you'll not get to know.
But like,
But in both the cases, it is acid. For us, it doesn't matter.
Yeah.
It will test on that. Okay. Is the product formed on burning acidic or basic? Can you write reactions for it? ठीक है. चलिए आगे. Wait, we were here. Chemical properties of metal. So let's look at the chemical properties of metal. What happens when metals are burned in air? Metals react with oxygen to form metal oxides. Such metal oxides will always be basic in nature, which means if you take the metal oxide, react it with water, it can either react with cold water, it can either react with hot water, or it can react with steam. ये तीन ही हमारे खासियत है. Okay. Now, all metals combine with oxygen to form metal oxide. This is a parent equation. So it's copper reacting with oxygen to form copper oxide, aluminum reacting with oxygen to form aluminum oxide. Now, recall that if you have a metal oxide, copper oxide reacts with hydrochloric acid. Let's try to think. Metal oxide reacting with hydrochloric acid. Metal reacting with acid will always give you a metal salt and will always release water. Now, question is, Al2O3 is oxide of aluminum, reacts with HCl. So you will get the metal salt, AlCl3. Whatever reaction is in NCERT book, इसको जरूर देख लीजिएगा. कहीं ना कहीं क्वेश्चन में आपको घुमा के बोल देगा, write the chemical equation for this particular reaction. At that time we will get up. So if you are reacting a metal oxide with a base NaOH, then also you are forming what? You will form a salt, but there is a difference. The salt that was formed earlier will be an acidic salt. The salt that is formed now will be a basic salt. And what we say, amphoteric पढ़ते थे ना, amphoteric oxides. So aluminum oxide is an amphoteric oxide, as well as zinc oxide is an amphoteric oxide. Such sort of an ion is known as aluminate. Similarly, you can also have zincate. NaAlO2. NaAlO2 is a salt of aluminum, salt of sodium aluminate, which will be actually basic in nature. ये समझ में आया तो? Al2O3 is your oxide, amphoteric, reacts with a strong acid, produces an acidic child, reacts with a strong base, produces a basic child. ये याद रखिए. Sodium zincate, zincate is ZnO2, वो भी बेसिक है. जिंकेट और एल्यूमिनेट, ये दो याद रखिए. हालांकि जिंकेट का मेंशन एनसीईआरटी में नहीं है, पहले वाले में है, तो जान के रखिए. जिंकेट एंड एल्यूमिनेट, देयर आर ओनली टू एम्फोटेरिक ऑक्साइड्स, एल्यूमिनियम ऑक्साइड, जिंक ऑक्साइड. Most metal oxides are insoluble in water. Coming again back to our story, but some of them dissolve in water to form alkali. So all bases are not alkali, but all alkalis are definitely bases. Sodium oxide and potassium oxide dissolve in water. If you are in group 1, then you will readily dissolve in water and you will form strong bases, sodium hydroxide and potassium hydroxide. Clear yahan tak? Chaliye. Next. So we observed in 3.9, all metals do not react with oxygen at the same rate. Different metals show different reactivities towards oxygen. Very common. If you take sodium out from kerosene, it will react vigorously. Sodium reacts vigorously. But however, there are some metals which are everyday exposed to oxygen. They don't react. For example, the iron karai that you have at home does not react with oxygen straight away. Some will react with hot oxygen when they are heated. Okay, so let's see. In this, we will be seeing questions of what you call sodium. Sodium is kept under what? Kerosene. To actually do two things. One is to cut off the supply of oxygen and also to give it a cool environment. Sodium's ignition temperature is very low. So ignition temperature is the temperature, minimum temperature at which a substance catches fire and sustains it. If you just catch fire, then it is called the flash point. Diwali mein kabhi hua hai, when you have a sparkle and you try to ignite it from a candle, not sparkle to sparkle. Sparkle to sparkle is very fast. Sparkle, जो आपका फुलझड़ी है, with a candle. Then somebody or elder somebody will पकड़ रहो, आ रहा है, चिरप 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 करेगा, उसको कहते हैं हम फ्लैश पॉइंट. उसके बाद क्या आएगा? फायर पॉइंट. It will catch fire, like typically in agarbatti. Put the agarbatti into a candle, it will immediately catch fire. The moment you take out, the fire goes away. My dad used to in childhood call me, तू पापी है ना, इसलिए तेरे हाथ में नहीं जलता है. So we did not know the concept of flash point and fire point. After that comes ignition temperature. At ignition temperature, it will burn and it will sustain. आगे फ्लैश पॉइंट पावर पॉइंट आप हायर क्लासेस में पढ़ेंगे तो आपको बता दिया. फ्लैश पॉइंट देखा होगा सबने, जब आप कोई भी फुलझड़ी वगैरह जलाते हैं, चिड़िक 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 करते रहता है ना. सुना नहीं अभी? इंटरेस्टिंग बारे में सुनना है ना, तो सुनेंगे. ओके, hence to protect them from accidental fires they are kept in kerosene oil. This is the story of sodium. At ordinary temperature, surfaces of metals such as magnesium, aluminum, zinc are covered with a thin layer of oxide. Always remember, zinc. That's the reason. What is galvanization? Galvanization is the process in which an iron article is dipped in a solution of molten zinc to create that layer of zinc. Zinc is more reactive than iron. Still, why are we coating with zinc? Because zinc is like Salman Khan. Once it will react with oxygen, it will form zinc oxide. और एक बार जो मैं zinc oxide बन गया, मैं किसी की नहीं सुनता. ठीक है ना? Similarly, that is with aluminium, as well as not chromium, as well as magnesium. Magnesium has this property. That's why ships, naval ships and all, right at their bow section, you will always have magnesium coating being done. Magnesium is coated on ships. The reason is magnesium is very reactive. Marine water में रहेगा, फिर भी कोट कर रहे हैं, क्योंकि एक बार जो magnesium oxide बन गया, उसके बाद to react and penetrate it is very, very, very tough. So that's why they have written at ordinary temperature, surface of magnesium, aluminium, zinc, lead are covered with thin oxide. Means the moment you scratch aluminium, the moment it will oxidize. You cannot get a time. The protective oxide layer prevents the metal from further oxidation. Iron does not burn on heating, but iron fillings burn vigorously when sprinkled on a burner. You know, that is actually attributed to surface area. Iron, see, if you want a reaction to happen fast, you should increase the surface area. So when you make fillings and you make chips, surface area बढ़ जाता है. The amount of surface area in contact will increase. That's, I don't know whether you know, if you have a campfire type fire going on and you take atta in your hand and if you say Om Him Krim Chamunda Namah ऐसे मार दिया ना, बजाम करके आ जाएगा पूरा. होगा. Large fire. There's been an accident in Uganda or Nigeria. This is reported in Cambridge books also, where fire broke out in a wheat mill where all wheat particles ने explosion हो जाएगा आटा. Atta is a dangerous thing. Sawdust. A piece of log will not burn, but if you take the sawdust, उसका surface area बहुत बढ़िया है. उसको ऐसे जैसे फेंक दोगे ना, immediately burn हो जाएगा. कभी ऐसे ही घर में कुछ bonfire हो रहा है, थोड़ा आटा फेंक के देखो तो, मूवी में जो सीन होता है ना, ओम हीम क्रीम चामुंडा नमः, वो सब आटा फेंकते हैं. आटा फेंकने से एकदम आटा is burned vigorously. Okay. Then iron when sprinkled on the flame of a burner will, sometimes you will also see if your burner is actually corroding off and giving small particles, आपको चिटक चिटक उसमें से भी burning दिखाई देगा. Copper does not burn, but the hot metal is coated with black color of copper to oxide. See any AC pipe, all AC pipes will have green coating. Green coating are due to copper carbonate and the black coating is copper oxide. And the rusting of copper is a combination. You have learned in grade 8. Copper carbonate and copper oxide together is known as the rusting of copper. You won't see only one color. So when you're waiting for my class next time, just have a look at the AC pipes. You'll see some green coat, some black coat. Green coat is happening due to the carbon dioxide in the atmosphere. Black coat is happening due to the oxygen in the atmosphere. Silver and gold do not react with oxygen even at high temperature. हमें तो कुछ फर्क ही नहीं पड़ता, हमें जितना जला लो, right? So after performing activity 3.9, this is that. Okay, anodizing. Anodizing is a process which we use in our metal industry a lot. Anodizing, nowadays you get Amazon Solimo anodized karhai. Anodized karhai. Anodizing means it will create one layer and that layer will actually, it's not Teflon coated. That layer will not allow further corrosion, also adds to the hardness. Like titanium anodized, they will say. You need certain amount of, these are called case hardening cases. Like say you have a product, the new Gillette Edge Tech Mac 3 shaving blade. Edge Tech means you need the sharpness only on the edge. You don't need the sharpness on the entire blade, cost बढ़ जाएगा. So that's called the case hardening, case sharpening. So anodizing can also be done for case. This is done for a lot of cars and automobile parts also, where you need hardening only say at the gear tooth. So anodizing will be done. In fact, in defense industry, anodizing is a major job. So anodizing is a process of forming a thick layer, oxide layer of aluminum. Aluminum develops a thin oxide layer when exposed to air. The main idea is aluminum oxide is highly rugged. It does not allow anything to penetrate inside. This aluminum oxide coat makes resistant to further corrosion. The resistance can be improved by making the oxide layer thicker and thicker. Nowadays, they are using a lot of anodized karhais, anodized frying pan, because people are moving away from non-stick frying pans. Non-stick frying pans, mein bola na. If you get a non-stick frying pan at a very cheaper rate, just don't buy it. You're buying poison. Yeah, you're buying poison. All Teflon will come out, and once Teflon comes out, it will mix with food, and it's not good for you. Oxygen gas. So it says during anodizing, ye dekh lo, during anodizing, a clean aluminum particle is made as the anode and is electrolyzed with dilute sulfuric acid. Oxygen gas evolved at the anode reacts with aluminum to make thicker protective oxide layer. So you will have an aluminum article which will be dipped in sulfuric acid, and the oxygen gas will evolve, and the oxygen gas will then react with the aluminum. आपको basically oxygen produce करना है. No. What is not there is not there. Nobody will ask you. But copper, green is not oxide layer. Green is carbonate layer. Copper's rusting is actually a combination of two type of things. Copper oxide, which will always be black. Please go and look at these copper pipes which are there in the AC pipes which you have. You'll see black copper pipe. और पास जाके देखो थोड़ा सा green coat. Black will be more, green will be less. Green is copper carbonate. Copper carbonate and copper. In fact, if you need anything, open up grade 8 Lakshmi Singh and it will just show you corrosion of copper. Copper carbonate and copper hydroxide together. They will form oxide layer, but with little bit of acid cleaning, it cleans up.
Directly copper 2 or 3.
Which one? Copper is never 2, 3. Copper is 2 or 1. Cu2O and CuO. CuO is copper 2, cuprous, and Cu2O is cupric. Sorry, us is the lower one. Cu2O is cuprous and CuO is cupric. We don't write all this in IUPAC. Now we write copper 1 oxide, copper 2 oxide. Copper 1 oxide is Cu2O. Oxygen's oxidation number is -2. Copper's oxidation +1 हो गया. दो copper है तो इसका मतलब copper's oxidation state is +1. Good. Clear? Do you know में डाला है ना. Generally ये एग्जाम के लिए क्वालिफाई नहीं करता है, बट यहां से क्वेश्चन आपको पूछ देगा. जैसे आपको एल्यूमिनियम एनोडाइजिंग के ऊपर डेफिनेशन नहीं पूछेगा, एमसीक्यूज में घुसा देगा.
बायो में भी रहते में भी
पढ़ना बेटर है. एक आप काम करेंगे ना, जब हम व्हेन वी आर डूइंग लॉट ऑफ सैंपल पेपर स्टडी, इफ वी कम अक्रॉस समथिंग, we will keep our books beside us. If we see that at least if one question is also hitting from here, that means बीमारी तो यहाँ से फैल ही सकती है. स्कूल के ऊपर मत जाइए. I am saying don't even go by the sample book question. Take a pure CBSE board paper which is a established CBSE paper, not even a CBSE sample paper. CBSE board paper करते करते अगर कहीं भी यहाँ से आ गया तो आएगा. Okay, next is what happens when metals react with water. Now water can be in what form? Cold water, hot water and steam. So देखिए, metal plus water will always give you a metal oxide and will give you hydrogen, and a metal oxide plus water will give you metal hydroxide. This is the basic reaction that you should know. Metal plus oxygen will give you a metal oxide, and metal oxide further will react with water to form metal hydroxide. When you react metal with water, you are forming metal oxide. तो भाई hydrogen कहाँ गया? Hydrogen will evolve out. Again, test of hydrogen question may be asked out here. Pop sound if you bring. So metals like potassium and sodium react violently with cold water. So right now we are analyzing cold water. In case of sodium and potassium, so just see potassium. Now since this reaction is mentioned, you should know how to write this reaction. Potassium reacting with what do you call water, sodium reacting with water. The technique to remember this is, if you know one reaction, there is no issue to remember another. The other is just the replica of that, because both belong to the same group. Potassium and sodium belong to the same group. So if this one is reacting with 2H2O, this one will also react with 2H2O. Forms KOH. KOH is known as potassium hydroxide and caustic potash. Caustic potash. NaOH is known as caustic soda and sodium hydroxide, king of base. Which one? Highly reactive है ना? ये cold water के साथ directly react कर जाएगा. This will form. That is what you should remember. If you are reacting highly reactive metal, they will immediately form hydroxide and release hydrogen plus release heat energy. That's the reason this reaction becomes very violent, vigorous, because not only it is exothermic, you are also releasing hydrogen with it. Therefore, it will burn with trap करके जलना शुरू हो जाए. Uncontrolled burning होता है. Any sodium salt after test, many children empty the test tube into the wash basin. जैसे आप wash basin में डालोगे, ब्राम करके से fire आ जाएगा. So be very careful when you are testing next year with any sodium salt. The reaction of calcium with water is less violent. The heat evolved is not sufficient for hydrogen to catch fire. You will revolve hydrogen, but you will not have sufficient heat for hydrogen to catch fire. Remember this. When group 1 metals are reacting, they are forming hydroxide, understood. They release hydrogen. Similarly, group 2s also release hydrogen, but group 2s do not liberate that much heat as group 1. In group 1, the heat is much enough to actually cause the hydrogen to burn, making the process more vigorous, spontaneous, whatever you call it. ठीक है? Calcium starts floating because the bubbles of hydrogen gas formed stick to the surface of the metal. ये भी important. When you burn calcium, why is the float observed? 1 mark question if someone asks you. The float is observed because the bubbles of hydrogen is because which sticks to the body. Magnesium does not react with cold water. Very interesting. It reacts with hot water to form magnesium hydroxide and hydrogen. To form magnesium hydroxide and hydrogen. They have actually shown it in one step. So magnesium reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen sticking to surface. Metals like aluminum, iron, zinc, iron के कढ़ाई बनते हैं इसलिए, do not react either with cold or hot water, but they react with steam to form metal oxide and hydrogen. Now here it is interesting. In the previous two cases, you saw metal hydroxide being formed. One was cold water, one was hot water. Now you are taking something which is called steam. Steam means the dryness fraction of water is almost 1. It is absolutely dry. Steam is also water, right? H2O in G form, but the dryness fraction is almost 1. There is no sort of moisture in it. In such a case, you will not see the formation of metal hydroxide. You will see only the formation of metal oxide and the release of hydrogen. So children, let's get this very clear. If you want to document also, you can document the reaction with water. Okay, when metals plus water can be of 3 types: cold, hot, steam. Whether you are reacting with cold, if you react with cold, you will form MOH, you will form MOH, you will release hydrogen, you will release hydrogen, you will release energy if group 1 metals are reacting, means sodium and potassium. Agreed? Then metal hydroxide, this is hot water, and no energy for group 2, that is calcium. Magnesium does not react at all with cold water. Now comes hot water. In hot water also you will get hydrogen. In steam also you will get hydrogen. But the only difference is in steam you will get MO, not MOH. ये याद रखिए. And in group 2, when you react with hot water, in that case you will float whether you are calcium or you are magnesium. यही कहते हैं माइंड मैप बनाना. इसी का आप एक माइंड मैप बना के रखिए. You float because the bubbles of hydrogen stick to the metal surface. So what all did we understand? With cold water, group 1 will react. they will release hydrogen. They will release sufficient amount of heat energy to make the reaction more violent. Now let's move to group 2. They will react with cold water. Do they like calcium will react with cold water? It does react. Magnesium will not react with cold water. If you react it with hot water, in both the cases, they will form metal hydroxide. They will release hydrogen, but the metal will be actually floating on the surface because of hydrogen getting stuck to the metal surface and create hydrogen bubbles. And the third is some metals like iron, zinc, aluminium. They react only with steam. In such a case, they don't form metal hydroxide, they form metal oxide. But the formation of hydrogen in all three cases are seen. Samjhing. If you read like this, you will understand, you will forget. If you make your own mind map, you will not forget. ऐसा एक बना के रख दो. जब टेस्ट आएगा उससे पहले टॉयलेट सीट के सामने लगा लो, रोज देखते रहो. हो जाएगा यार. Metals with acid. Come on, tell me. Metal reacts with acid to form metal salt and release hydrogen gas. An acid can always be represented as HX. Reacts with a metal to form MX and releases hydrogen gas. This we also saw in acid, bases, and salt. So it's a combo question that can come. So, but do all metals react with acid in the same manner?
No.
Acha, there are some acids. HCl, H2SO4 shows the same thing. HNO3 has an issue. HNO3 is oxidizing in nature, so it will oxidize the hydrogen and form water in the process. However, magnesium and manganese can actually are exceptions in this process. तो फिर से सुनते हैं बात क्या है. Whenever a metal reacts with acid, it will form metal salt and release hydrogen. When we talk about acids, the mineral acids that we deal with, carbonic we don't consider because it's a weak mineral acid. So we'll be dealing with sulfuric, HCl, that is, and HNO3. With HCl and HNO3, this reaction holds. With HNO3 is very oxidizing in nature. What is oxidation? Oxidizing means I am an oxidizing agent. I oxidize him. I oxidize him means he combines with oxygen. So I oxidize him. So this fellow becomes water in the case of HNO3. However, there are two metals which do not allow HNO3 to show that oxidizing nature. Those are magnesium and manganese. Waiting?
Yes.
Okay. And then comes reactivity series. I hope you know reactivity. Please stop calling me a zebra. Instead, try learning how copper saves gold.
Sir, while you were teaching us that reactivity thing, why did you add carbon in between?
That is because when you go to higher classes and you study electrochemistry, that time you will need carbon. Carbon is a non-metal, hydrogen is a non-metal. You'll learn about something called standard hydrogen potential or standard carbon potential. That time you'll need it.
Is there in this lab manual? That's what.
But it will be on the top only. Right?
Yeah.
Kiss top.
Top.
Reactive. It's in group 1, end of the day. Okay. Then comes aqua regia. Again, do you know our report? So aqua regia is, remember, it's a freshly prepared solution. Just like sugarcane juice. Never drink sugarcane juice if he just gives you from a matka. That means the juice has already become toxic. Sugarcane juice is to be freshly prepared and given to you. That's why you'll see any roadside sugarcane juice seller, suppose there is any extra juice, he will not keep it. He'll try to top up. But they are also very clever. They make it only in such a way that it just comes up to 1 glass. But if there is some newbie in the town who does not know and some excess juice has got extracted, वो आपको पिला देगा, रखेगा नहीं. Sugarcane juice is never to be bottled. Similarly, the same thing out here. Aqua regia is a freshly prepared. You don't prepare and keep it. And it's prepared in the ratio of 3:1. So you're preparing hydrochloric acid is to nitric acid and it can dissolve gold. All goldsmiths have that. Very reactive. This solution is dangerous. Okay. Next, how do metals react with solution of other metal salts? Metals reacting with other metal salts. So the question will come off.
Yeah.
Take your girlfriend away वाला question क्या था? Displacement. हाँ, मैं तुझको भगा लाया, है ना? Metal reacting with a metal salt. solution. So metal will react with the metal salt, so I can displace. New metal salt will be formed. Single displacements are always oxidation reduction. Double displacements do not have oxidation reduction. What is the time, by the way? Oh, we have time. All right, let's go ahead. Reactive metals can, it should come in your mind. Metal and metal solution. Displacement hoga na. A more reactive metal, there is what, see, once I say displacement, you will be able to answer because your trigger has happened. What is a displacement? A reaction in which a higher reactive metal displaces a less reactive metal from its salt solution is called a displacement reaction. पहले trigger हो जाना चाहिए. Metal reacting with metal solution. So we have reactive metals can actually take out. So some of the common questions that they can ask you is, let's say Cu plus ZnSO4, and the reaction is written as CuSO4 plus Zn. But that is not possible, though by mathematically we can write it, but real life it is not possible. ZnSO4 plus Cu is equal to ZnSO4 plus Cu? No. Okay, Zn plus CuSO4. Let's see the reaction of Zn plus CuSO4. So you have copper sulfate, which is actually blue in color, and you dip a zinc strip into it. Then what are the reactions? What are the observations you'll find? The blue color of copper sulfate will go away because now it has become zinc sulfate, and copper was released. So you'll see some goldenish layer forming on the zinc strip. That is nothing but the copper which is getting deposited on the zinc strip. Okay. Which metal, copper, iron is more activity? We know our formula straight away. Put your formula. What is the formula? Please stop calling me a zebra. Instead, try learning. So this is your reactivity series. Any questions so far? Because I've been bugifying for last 50 minutes. Got tired of it. So far, okay? What are you doing in school now? Annual day practice.
Yeah,
Yes.
How many of you have become donkeys or dwarpal or trees?
Sir, I was an old man in the play.
Old man.
We don't have an annual day. 1 year we hold a cultural show.
Yeah.
1 year we have a science.
So this year is a science exhibition. Yeah, they were telling me, the other two girls.
Sorry
Okay.
for the urine.
And otherwise there are some children are there who every year becomes a bear. हाँ. और पेबल में मैं एक देखा हूँ, एक बच्चा हर साल ऐसे सुबह सुबह बेयर बन के जाता है बस स्टैंड में. Bears years have become smaller now. Hey, what about in time school? You have 100% participation annual day. Hey Fazu, what is your system in school? Do they make you dwarpal or forest tree? You can move out also.
And privilege of planning the most of the stuff for us.
There are some schools where there are like 100% participation. Child is becoming every year one dwarpal. तुम क्या बनते हो बेटा? जिराफ. अच्छा.
बाहर गया.
इस साल क्या बन रहे हो बेटा? कुछ और? सील, हिपोपोटेमस.
No, I
क्या प्रैक्टिस मतलब?
annual day.
अरे एनुअल डे तो समय प्रैक्टिस किस चीज का? प्रैक्टिस चोरी डकैती लूट मार किस चीज का प्रैक्टिस करोगे? मैं प्रैक्टिस करूंगा कि किस चीज का प्रैक्टिस? प्याज काटने की प्रैक्टिस करोगे क्या? चले. How do metals and non-metals react? So question comes again, how do metals and non-metals react? At the end of the day, the story comes down to the story of electronic configuration, right? Metals and non-metals. So metals and non-metals means, see, I told you, though we have got covalent bonds and ionic bonds, in this part of grade 10, we will be concentrating only on ionic bonds. So before studying this, let us just understand ionic bonds. Ionic bonds are also known as electrovalent bonds. Electrovalent bonds. For such set of bonds to be created, ions must be formed. Ions are of two types, cation and anion. Both are oppositely charged particles, and oppositely charged particles attract. Yes, na? अभी birthday आज देखो तुमको नहीं बुलाया, किसी और को बुलाया होगा. They attract, and that attraction is very strong. है ना? You cannot just break it. So ionic bond is said to be a very strong bond. And usually we say that this bond is formed by transfer of electrons. So when you transfer electron, there will be a donor and there will be a receiver also. Somebody will receive the electron. That means that the transaction is smooth and clear. Whereas in covalent bonds, we used to have sharing. And that's why covalent bonds are weak bonds. Ionic bonds will give you very, very stable compounds. So we don't call the compound that has been created, we don't call it a molecule, we call it a formula unit. In ionic bonds, we don't call it a compound like NaCl. We don't say that this is the molecular formula, we say this is the formula unit. And also in higher chemistry, you will not say molecular mass of NaCl, you will say formula mass. Formula mass, formula unit. So this is the story of ionic bond. Let's take some small example and try to see. Na has an electronic configuration of 281, right? So either it needs 7 electrons or somebody has to take away this 1 electron. So Na starts looking for a suitable partner, which is 287 chlorine. Chlorine will take this 1 electron and become 288, and it will have the electronic configuration of argon, the good boy in its colony. Sodium will become 28, becomes the good boy of the previous colony, that is neon. So if we look at sodium, sodium will become sodium plus and lose 1 electron. This sort of bonding can happen only when there is a perfect match between a donor and an acceptor, something typically like the share market. If you want to sell a share, there has to be somebody who is ready to buy the share, otherwise the transaction will not happen. Okay, so similarly we will have chlorine, it will actually accept this electron and become chloride ion. And then if you actually add up these two equations, then E and E cancels each other and it forms NaCl. These compounds will be very stable. That means their boiling point will be very high. Their melting point will be very high. You cannot melt salt so easily. Melt ही नहीं होगा. Clear? My next question is, will they conduct electricity? Well, since they are formed of ions, in their aqueous or molten state, they will conduct, not in solid case. Aqueous or molten state, they will conduct. So, आज रख लेंगे नहीं तो. How do metals, how many we are left with? We'll continue from here in our next class then. So, we start with refining बाद में. First of all, your hunger should be to get a metal. Metals are not available in free state because after all, a metal is not an inert element, so you won't get it as a free state. It is always found in combined state. It will be combining with either some carbonate or in a carbonate form or an oxide form. So our job is now to extract these metals. First of all, we will extract these metals, and then after extraction of the metal, then we have to also purify the metal, है ना? अब बाजार से लौकी बैंगन लाके थोड़ी आप सब्जी बना लेते हो, फिर उसको आप प्यूरिफाई करते हो, धोते हो. तो सबसे पहले हमें क्या करना है? मेटल्स का ऑकरेंस, एक्सट्रैक्शन, इसके बारे में पढ़ेंगे. थोड़ा सा ज्योग्राफी भी इसमें देख लेते हैं. ज्यादातर मेटल्स कहां से पाए जाते हैं? वी गेट देम फ्रॉम द मिनरल्स, राइट? एंड द मिनरल्स आर फाउंड ऑल बिलो द अर्थ्स क्रस्ट, एंड द जॉब of extracting minerals from the earth crust is known as mining. Okay, now there's a thin line difference between something called a mineral and an ore. A mineral will have the metals present in the various compounds in it, but those minerals from which I can extract the ore economically, technologically, means economically means after spending so much of rupee I got only this much, but if I extract from him I get a lot, so I will call him as a ore for this particular element which I am trying to mine out, rather than calling him as the ore. Have you understood what I am trying to say? A mineral from which a metal can be extracted somewhat easily and also economically, where your return of your investment is more. So that, like for iron we say hematite is an ore of iron. Okay, so zinc blend, ZnS, copper blend, pitch blend, and mercury we say pitch blend and all. So you should be able to extract that element in a more economic as well as easy manner. Have we understood? So some parts which are no more studied, but you should know that whenever you get an ore, so we specify some ores, and there are belts of geography which are rich in particular ore. So for example, the ore of aluminium is bauxite. Bauxite is not aluminium. Bauxite is something which has lots of aluminium and some unwanted substance which we don't want, which we call as impurity, which is an impurity, right? We'll come to gang. We'll call that as impurity. For example, if you are mining for iron and you get gold, in that case, gold is also an impurity because you are mining for iron. Though the impurity has more value for you, आप impurity को चुराना भी चाहेंगे, but the metal that you mine, that is of prime interest. So first, when we get the ore particles, our job is to crush the ore. We crush the ore, we make a fine powder of it. Then we'll do some, typically it's just like making vegetables. You'll first wash it. We call it hydraulic washing. So in hydraulic washing, lightweight particles, which are generally the dust and all, they actually get moved away. And there are various processes like gravity separation, then they will put on roller belts. The belts will shake as they move. It's just like the process of winnowing that our mothers used to do in our childhood days, when the grain particles used to stay back and the husk particles being lighter used to fly away. So when you do it on a gravity separation roller, then the ore particles being hard are remain back, and the lighter particles move away. So at that time, whatever we are throwing away are all known as our gangue, or gangu, as we say, GANGUE. So all the gangue particles are going away, and then what you are left with is all called as your ore. That's your rich ore. And from that rich ore, we are now going to extract our metal. Okay. So the metals, when we study in this chapter, we will classify them into three categories. One is being a very reactive group, then will be a moderately reactive group, and the third will be least reactive. So our idea is, if you have a very reactive can be extracted only by electrolysis. That is, electric current is the only way in which we can extract it. The moderately reactive one, we will try to convert it into its oxide, and once we have converted anything to oxide, we will try to reduce it. We will reduce it. Reduction is the process of stripping out the oxygen. Your job will be to convert it into an oxide. Once an oxide has been formed, our job is to reduce it. And how do you reduce? By just stripping out the oxygen. We will see how to strip out the oxygen. Means we have to introduce something. I'm an oxide, so I have oxygen paired with me. You want me without the oxide. So you have to bring someone who will love the oxygen and take it away and leave me free. So that is one. And the least reactive ones, where the least reactive ones are done directly. Directly, if you reduce it, it works out. If you get it from their sulfur or whatever ore. So that's basically the story. We generally study it in our course. Sodium will be taken as one example. So we'll go one by one. Okay? Itna tak sabko samajh mein aaya? Right. So let's go one by one. So this is the flow chart which you should remember. So before we start, the flow chart is something, you have an ore. Ye hamesha yaad rakho. So ores are basically, you will have HR, highly reactive, moderately reactive, and least reactive. If you are highly reactive, then electrolysis is your only savior. If you are moderately reactive, then we have to see how you are getting it. How you are getting it. In our course, we will get it either as a sulfide, okay, or we will get it either as a carbonate. This is where children get confused. So isko thoda dhyan se dekho. Sulfide or carbonate, right? In both these processes, we have to convert them into what is known as their oxide, and further we have to undergo reduction, and that you get your metal. Okay. Now, when you do reduction for oxide, the thing that you use is carbon in the form of coke. So carbon will react at high temperature with the oxygen, form carbon dioxide and get out and leave your metal. Now comes this stage. If you get a sulfide or a carbonate, so I always say you need some techniques to remember. Carbonate comes with C. So here we will do calcination, and again with the word C. And the other one, what we will do is known as roasting. Roasting is like making chicken roast at home, and our kitchen has a lot of oxygen. So roasting is always in the presence of oxygen. Calcination is in the absence of oxygen. This is how you remember. Carbonate C undergoes calcination. Therefore, these two processes you have to know, roasting and calcination. So if calcination you have been able to allot, then roasting इसी को जाएगा. अब आता है किस में ऑक्सीजन है किस में नहीं. Roasting is like chicken roast, paneer roast, ghee roast, whatever you make. All these you make in your kitchen. Kitchen में ऑक्सीजन है, बिल्कुल है. तो roasting हमेशा ऑक्सीजन के प्रेजेंस में होता है. Calcination is absence, and both these processes are strong heating. Strong heating. One is in the presence of oxygen, one is in the absence of oxygen. Okay? And then you convert into oxide, and once you have got into oxide, then you do it. In low reactivity, we will, in our chapters, what do you call syllabus, we will just see sulfide. Sulfide means straight away roasting, and straight away you get your PM, which is known as your pure metal. Are we fine? And then further, we also see some electrolytic refining of copper. है ना सिलेबस में 10th में, हाँ 8 में भी रहता है, हाँ इलेक्ट्रोलाइटिक रिफाइनिंग. ये याद रखिए, इसके ऊपर बहुत सारे क्वेश्चंस हो जाएंगे इन केस बेस्ड स्टडी. सो आर वी फाइन? शैल वी रिवाइज वंस अगेन? फर्स्ट ऑफ ऑल, व्हाट यू गेट? ओर. देन द प्रोसेस इज नोन एज concentration of ore. Concentration of ore is simple. You want to make matar kachori, so what did you buy from market? Peas. But do you want the shell of the pea? No, you just want the pea grain. So concentration of mutter means chilo and throw away all the shells. So that is called concentration of mutter. So concentration of ore. How do you concentrate an ore? Take a ore, crush it into small particles, wash it, throw away all unwanted impurities. How can we throw away unwanted impurities? Hydraulic washing is one process. Magnetic separation for iron. If you're dealing with, say, iron type of ore, then what will you do? You will do a magnetic separation. Then many children ask, sir, if you use a magnetic roller, the magnetic roller will attract all iron. इसके बाद क्या करेंगे सर? स्पैटुला लेके स्क्रैप करेंगे क्या? इलेक्ट्रोमैग्नेट्स है वो, जैसे ऑफ करोगे छनाक करके सब आयरन गिर जाएगा. देखो कितना वेरी गुड. ठीक है, सो सारा आयरन आपने मैग्नेटिक सेपरेशन यू कैन डू. देन वी विल डू हाइड्रोलिक वॉशिंग. देन वी विल डू ग्रेविटी सेपरेशन मेथड, जग 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 करके. तो ऐसा करने के बाद ऑल वी आर लेफ्ट विद दिस ओर, and those ore are known as concentration of ore. After the ore has been concentrated, obviously you will not do a industrial process this way. अगर आप plant है तो सिर्फ इसका plant बनेंगे या इसका. But as a student you should know everything. Now since you have got all the ores concentrated, then what do? You will see which type of ore are you dealing with. Highly reactive, electrolysis. Less reactive or moderately reactive, then we have to see. In our syllabus, we will encounter either a sulfide ore or a carbonate ore. Carbonate is having a C, that means it goes for calcination. Other one is roasting, which is allotted to sulfur. Both are strong heating. Calcination, absence of air. Roasting, presence of air. How do I remember? All chicken roasts are prepared in kitchen. Kitchen has oxygen, so oxygen, yes, chai.
Sir, what was the gravitation thing you were saying?
Gravity separation method. Hydraulic washing, gravity separation, magnetic separation, but these are not mentioned in your textbook. This is only for your interest. जैसे no, but it's in. See, now I am teaching you, which I hate. I am teaching you not for knowledge build-up. That I did throughout the year. Now I am teaching you to turn you to a beautiful parrot who can learn and puke exactly NCERT contents into the paper and get that 95 plus marks. Sir, you are talking like this? Yes. Because the world needs marks. वो knowledge, ज्ञान जो है वो अपनी जगह, वो सब मैं बक सकता हूँ because I have passed 10th. You have not passed. आपके लिए your identity is your mark sheet. So now be very, very crucial to what you are studying. Do not study extra. Nothing comes. See, the pain will be what, when you have more knowledge, but someone scored more than you because he was a better mugger. Mugging up guy. Everything that will be asked to you will be from NCERT. Nothing beyond NCERT. So anything that you have studied outside, too much knowledge, sir, I read that book from that Italian writer, but I did not read this equation and this one came. Then who is the idiot? You are the idiot. वो नहीं करना है. ज्ञान चाहिए तो पुराने वीडियोस देखते रहो ना. ज्ञान ही है. एक चैप्टर we have taken 5, 6, 7 classes. है ना? Like in grade 9 there's a chapter called structure of atom. This much chapter. Nothing. But when I taught them, I took some 8 classes only on explaining atomic chemistry. But from there maybe your knowledge builds up. But अभी आपके लिए क्या चाहिए? You should be able to puke. ठीक है? Done. So shall we go? Enrichment of that process is known as enrichment of ores. One enrichment. You get the ore, you do its concentration, and that process, whatever above I told, those are known as your ore enrichment process. So extraction of metals, low in the activity series. So they have started in ulta way. Low in the activity series. Low means in NCERT the story is starting from this side. This side. Low. So the two things that we have, लिखना शुरू कीजिए, we have is mercury and copper. But the interesting part is mercury is a low reactive one, so it's is in a sulfide ore. Sulfide ore है तो बेटा हम क्या करते हैं? Roasting मतलब we will treat it with oxygen and there will be strong heating, so you straight away get mercury oxide and you will get sulfur dioxide, which is a gas. This is your solid, this is gas, and this is solid. Remember the balancing. If you practice it properly, it will be coming quickly. Otherwise, वहाँ पे hit and trial मारने की कोशिश मत करो. आपका time लग जाएगा. How many sulfurs? 2 sulfurs, 2 mass. Acha. One good thing is these low reactive ones. When you get, what did you ultimately get? You got an oxide. Now there's a difference. while these need carbon, these do not need carbon. यहाँ पे carbon की कोई जरूरत नहीं है. You just heat it. If you just heat it, the oxygen will go out. This is also you should remember. We got what? Mercury oxide. Now mercury oxide will be straight away heated. HgO. And you heat it. Mercury as a liquid will come out and oxygen as a gas will separate out. Bas. याद रखना this equation. Vaibhav, this is important, huh? This they can ask in any form. Somehow they may not write you right this. They will say then this is a low reactivity. Write a reaction, balanced reaction to represent the scenario. So at that time, what do? फजू आराम से you didn't miss anything. पुराना थोड़ा सा ही कहानी गया है, ठीक है? Another that we have in our example is copper sulfur, pitch blend, हाँ copper sulfide. अब यहाँ बड़ा interesting है, copper sulfide, Cu2s. The oxidation state of copper in this is 1. This is copper 1 sulfide, not copper 2. Q plus. Okay. So again, low reactive. Please stop calling me a zebra. Instead, try learning how copper saves gold. ये सब नीचे है. Very low reactive. तो क्या करेंगे? And you see that it is a sulfide ore. So straight away heat it with oxygen. All you expect to get is copper oxide, but copper 1 oxide. Copper 1 oxide means Cu2O. Oxygen is -2, copper is +1. 2 of +1 makes it +2, balances it. याद रखिए CuO मत लिख दीजिएगा. And also you will get SO2. बैलेंस कर लीजिए. तो Cu2 इसमें 2 सल्फर डाल दिया, इसमें 2 कर दिया. 2 ऑक्सीजन कितना हो गया? यहाँ पे है 2 ऑक्सीजन 2. सो इसमें भी इसको 2 कर देंगे. एंड ऑक्सीजन कितने हो गए यहाँ पे? 2 ऑक्सीजन. और यहाँ पे कितना है? 4 and 2 6. सो यहाँ पे 3 डाल देंगे, 6 ऑक्सीजन. ठीक है. Now this is my solid, this is gas, this is solid, and this is gas. And further what will I do? I will heat this. इसको heat करते ही copper बाहर आ जाएगा and O2.
Sir, the equation is
Oh, sorry. Not heat. One minute. Here there's a change. Cu2O. This reaction in your syllabus. I just missed it. This reaction in your syllabus बड़ा आधा करके मतलब short में बताया है. After 50% formation of copper oxide, 1 oxide, the copper oxide then further reacts with copper sulfide, which was there, and then will give you copper and sulfur dioxide. See, this reaction is important, though we don't study it. This gas is very important gas in industry. सल्फर डाइऑक्साइड, इसका एक प्रोसेस है जिसको हम पढ़ते हैं कॉन्टैक्ट प्रोसेस. कॉन्टैक्ट प्रोसेस इज द प्रोसेस यूज्ड टू मेक सल्फ्यूरिक एसिड फ्रॉम सल्फर डाइऑक्साइड. So sulfur dioxide is a raw material in that process. Where do you get sulfur dioxide? So these industries which mine, they sell this gas. Either they sell the gas or they have an additional plant which will be manufacturing also sulfuric acid. Sulfuric acid is a high demand product. तो इसको जैसे आप यहाँ पे ऐसे लिख देते हैं ना, छिलके की तरह लिख दिया, ये बहुत इंपॉर्टेंट प्रोडक्ट है. ठीक है. सो दिस विल रिएक्ट विद कॉपर ऑक्साइड, विल रिएक्ट विद कॉपर सल्फाइड, द सेम कॉपर सल्फाइड, Cu2s, and now we'll give you copper oxide. Heating will not, mercury is a liquid ना, वो अलग हो जाता है, कॉपर नहीं होगा. Copper plus, again you will get SO2. So ये balancing है. 2 copper, 3 copper, 3 नहीं, it will be 4 CuS I think. नहीं, 2 CuS, 2 अच्छा 2 CuS नहीं 2 4 2 6, हाँ 6 हो जाएगा यहाँ पे. और सल्फर 2, ऑक्सीजन 2, yes. So remember again the story of this. ये आपको छुपा के पूछ लेगा. After 50% the reaction has progressed, the same copper oxide will further react with the reactant copper sulfide itself and will give you copper. इसी copper का हम आगे जाके इलेक्ट्रोलाइटिक रिफाइनिंग पढ़ेंगे. ठीक है ना? प्योर नहीं है, इम्प्योर है. इसको और प्योरिटी चाहिए. तो अभी वो वाला पार्ट पहले खत्म कर लेते हैं, तो एकदम खत्म हो जाएगा कॉपर का. इसके बाद फिर से आएंगे. ठीक है. सो if we are studying for extracting metals which are low in the reactivity series, what all qualifies in your syllabus? Tell me. Mercury, and copper. Both will be in their sulfide form. Sulfide means roasting. Mercury straight cut. Roast it, get mercury oxide, heat mercury oxide, liquid mercury comes up. Copper will be in copper 2 oxide, copper 1 oxide. Heat it, it will give you copper 1 oxide. Copper 1 oxide again reacts with the copper sulfide, gives you 6 of copper.
They can't be near the economic mercury and copper.
Okay. This copper is not pure copper. So we'll now look how do you do electrolytic refining of copper. Though it is at the later stage, but since ये आ गया तो उसको खत्म करके आगे बढ़ते हैं. ठीक है. So let's understand electrolytic refining. So electrolytic refining and all takes place in a tank, and this tank is known as electrolytic tank. Electrolytic tank.
So isn't it also called electrolytic cell?
Cell or tank all same, but what you should not use the word is electrochemical. Electrolytic tank is a tank where electricity will be a raw material, right, and chemical reaction will be the output. Electrochemical is a tank where chemical reaction is the input, electricity is output. Like the battery is a electrochemical, तो cathode anode पूरा अलग हो जाएगा उसमें, ठीक है ना? So this is an electrolytic tank. So in an electrolytic tank, the process that we will follow is we will take our impure copper is taken in this manner. This is my impure copper, and you have to bring a strand of pure copper. So let's say this is my strand of pure copper. Very thin pure copper we will be taking. Now apply your knowledge. You want copper from here to go here, and copper will go as ions. Metals. Metals are what? Positive ions, cations. Cations will always go to the negative side. So this will be connected to my negative terminal. Right? This will be connected to negative. So this will be connected to positive. Is this one understood? Right. So what are you trying to refine? You are trying to refine copper. Whether you are doing electroplating or you are doing electroplating or electrochemical refining, in both the electrolytic refining, not electrochemical, in both the cases, the electrolyte is always a salt of the metal whom you are refining or of the metal whom you want to deposit. Though plating is not in your syllabus, it was in grade 8. You want to plate with copper, then copper salt should be used. Now you're refining what? Copper. So we will use copper, and our lovely copper salt is copper sulfate. So take copper sulfate. So this is my copper.
Copper sulfate here also appears blue.
Yeah, copper sulfate will be blue because it is in hydrated form. All salts in hydrated form will be colorful. And copper sulfate has its unique color called blue. Is this understood? Vaibhav?
Yes.
So this will be my electrolyte. This is CuSO4, aqueous. And this will be blue in color. Understood? Right, fine. Then, since these are electrolytic tanks, so electrolytic tanks, we go by our same Cartoon Network, or don't panic. Positive is anode. Or don't panic वाला formula नहीं पता. Don't panic. इसको याद रखो. Positive is anode, negative is cathode. Positive is anode, negative is cathode. या फिर आंध्र प्रदेश एंड कार्टून नेटवर्क, ये भी याद रख सकते हो. ठीक है. Panic. Positive is anode, negative is cathode. Don't panic. और आंध्र प्रदेश AP, AP stands for anode is positive. तो इसका नाम क्या हो जाएगा? Anode हो जाएगा. इसका नाम क्या हो जाएगा? Cathode हो जाएगा. अच्छा, when you will go to grade 12, that time you will say, sir, said so many formulas, A, P, C, N. There it will become CP and it will become AN. So it is not wrong. The way you remember now, you're remembering with a very child technique. The correct way to remember is, in anode, always oxidation happens. That's the thing. That is the universal truth. Whether you are in this type of cell or you are in electrochemical cell, oxidation will always happen in anode. Oxidation always happens in anode. There you will find oxidation will be happening on the anode, and anode will be the one which will be connected to the positive, and it has to be connected to the positive. It is not that where you connect. अभी हम क्या सोच रहे हैं, हमने इसको पॉजिटिव में लगाया तो इसको एनोड नाम दे दो. वो करेक्ट नहीं है. वो ये अभी बच्चे फॉर्मूला के लिए करेक्ट है. द करेक्ट वर्ड इज, ऑक्सीडेशन किस में हो रहा है? सर ऑक्सीडेशन इस वाले पे हो रहा है, इस पे, इसका नाम एनोड है. अब टू हैपन दिस रिएक्शन, वेदर यू आर कनेक्टिंग इट एट पॉजिटिव और नेगेटिव, दैट इज अ सेकेंडरी मैटर. But since we are in electrolytic tanks, we need not bother about grade 12 now. In electrolytic, this formula holds. Whether you are doing electrochemical refining or you are doing electroplating, not electrochemical, electrolytic refining or electroplating. Positive is panic, positive is anode, negative is cathode. Yaad rahega? Understood? So let's see the reactions now. Okay. Now what happens? At anode, oxidation always happens. So what is happening at anode? Oxidation. You remember what is oxidation? Increase in oxidation state. And the best way to remember oxidation here is OIL. Oxidation is loss of electrons. Okay, loss of electrons. So copper will get converted to copper 2 plus and lose 2 electrons. Right. So this is at anode. And what is this process? OIL is happening. Samajhte jao. Detailed way mein. Okay. So it is losing 2 electrons. So what happens? Out here, you will find Cu2 plus will come out and 2 electrons will also be released. These 2 electrons are not released here. These 2 electrons are actually released in the circuit. Current to chalta hi rehna chahiye na? These 2 electrons are released in the circuit because nobody produces electrons. This is connected to a battery. Also, remember, this is always a DC source. Since you are in grade 10, somebody may ask you, is it AC or DC? It is high voltage DC. Nobody produces electrons. The DC source acts as a pump. It's only to kick the electrons and make it move in the circuit. So although I've written the 2 electrons here, but these 2 electrons are not to be seen here. They are a part of the external circuit. Have you understood? Cu2 plus. But before that, kahani mein, one moment before, kya hua tha? This CuSO4 is the first one which will split up. Cu2 plus aqueous and SO4 2 minus aqueous. This is the first thing which is going to happen. The first thing which is going to happen. And due to the potential negative out here, the negative potential out here, and they being positive, these two people means you had here what? Cu2 plus and SO4 2 minus. These ones immediately rush up out here. Right? Our friend Arafat gave me 10 rupees to buy a pen from Golchas. I kept the pen 10 rupees in my chest pocket. He needs a pen. So I went to Golchas, I bought it from my back pocket 10 rupees. And later I took this 10 rupees and put it in my back pocket. Let's see the transaction. Did he get the pen? Yes. Did Golchas get a 10 rupees? Yes. Am I having my 10 rupees? This one gone, but this one inside. All of us, equation balance. So this copper is going to get deposited out here. Understood? So when it goes that side, ये जो 2 electrons circuit में है ना, it will absorb these 2 electrons. So let's see at cathode. Let's see what is the reaction at cathode. At cathode, these 2 copper, Cu2 plus gains 2 electrons. Which are the 2 electrons? These 2 electrons, which are there in the circuit. And this is known as reduction. Reduction is Rig. Reduction is gain of electrons. Rig. This is oil, this is Rig. Gain of electrons, and it forms copper atom. So copper atom. So slowly you will find that copper atoms have started to deposit out here. Copper atoms have started to deposit. Agreed? Right? So let's see what all stories we have cleared. This copper, the electrons, these stories have been cleared, and this copper has gone here. Now we have still story about this copper and this sulfur. So this sulfur was standing alone, and this copper now comes and pairs up with this sulfur and reunites as copper sulfate aqueous. That's why during the entire process, the electrolytes level never changes. It remains replenished, nor will its color change also, because this is the reaction which is happening at the Atma level. On top, you will keep on seeing blue copper sulfate, blue copper sulfate, blue copper sulfate. However, as the time goes on, then you will find that the Ganesh has become thin and the rat of Ganesh has become thick. So Ganesh has become thin and the rat of Ganesh has become very, very thick. And finally, all copper has been. What is left? Impurities. So those impurities at one moment will make a noise करके से नीचे गिर जाएगा. इसको हम क्या बोलते हैं? Anode mud. Because the mud collects right below. गिर जाएगा ना यहाँ पे. Reaction stops.
So what's the remaining constituent of the pH?
Nothing. Anode is lost.
No, sir, but you said there's some part very left.
It is becoming thinner now. Have you burnt an agarbatti ever? All the essence part gone, then what is left? The stick is only left. A stick.
So what is that statement? I mean, there is
It will fall down. These are mud. These are the impurities. End of the day, these are the impurities. I have a nice example if you love cooking. So if you make something like paneer makhni or chicken makhni, butter chicken or paneer chicken, then what do? In a pressure cooker, you'll add a lot of tomatoes, you'll add a lot of cashew, you'll add a lot of green chilies, red chilies, and you will whistle de doge usko, pressure de doge, no oil, nothing. So all the tomato and a lot of onions, all the tomatoes and everything will become mushy हो जाएगा. इसको आप क्या करोगे? Strain करके थोड़ा सा पानी निकाल के बाकी को आप mixer में grind कर लोगे. Then you take it on a strainer. That's very tasty to eat, huh? Lots of butter and lots of cashew, and then on a strainer you just use your spoon, cut, and what you'll find is, have you sometimes taken out curd like that? जैसे रायते के लिए निकालते हैं ना, very cream जैसा निकलते रहेगा. That butter chicken or butter paneer कैसे cream जैसा निकलते रहेगा. And in your strainer, finally you will have some particles which no more strain off. What are those? The seeds of the tomato. The seeds of the tomato. ये और जाएगा नहीं, ऐसे रह जाएगा. ये आराफत को दे देने का. और नीचे जो अच्छा चीज है, that you can store in refrigerator. It will be thick, creamy, cashew and tomato and butter वाला. उसको जब आप पनीर बना रहे हो, उसको थोड़ा ऐड करो. Yummy. So it's the same thing, anode mud. So all you were interested in the copper, all the copper is gone. Now impurities are left. They will not hold together. After some time, blub करके नीचे गिर जाएगा. That is not the anode mud. Is this story clear? Anyone has a doubt? Remember one thing. These copper do not travel directly here. They travel via this source. This fellow has got lots of copper, but with one condition. I'm going to give my copper, provided you replenish me one. The one moment when his replenishment is over, he again says, "Tum kaun ho? Main tumhe nahi pehchanta hu. Kyun do tumhe copper?" And sulfate, which keeps on watching the entire show in higher class, is known as spectator ion. This is known as the spectator ion. It खड़ा खड़ा तमाशा देखता है बैठ के. इसका पल भर के लिए डिवोर्स होता है और फिर से शादी हो जाता है. अराफात क्या मजे से हंस रहा है. ऐसा एग्जांपल दे दो, लौंडे को समझ में आ जाता है ना. और यहाँ पे बाद में कॉपर के साथ आके and they lived happily ever after. Is it fine? Are we done with copper as an extraction? Any doubt here, Web, of anything? Rig and oil and all you have understood? Very good. Didn't understand?
No, sir, I understand.
Okay. So you're nodding your head sideways. So anyway, so this is gone, this is gone, this is gone. Now we are extracting metals in the middle of the reactivity. Middle वाले बड़े आसान हैं. So middle वाले कर ले. What was the story of the middle one? Tell me. The middle ones can come in carbonate and sulfide. If they are coming in carbonate, we will do calcination. Calcination is heating in absence of oxygen. If they are coming in sulfide, we will do roasting. Roasting is in presence of oxygen. In both cases, we will get either a zinc oxide or a zinc oxide. Either from zinc ZnSO3 or we will get it from ZnS. But our end product will be ZnO. And ZnO further will be treated with carbon. Carbon is a very, in geography you must be learning. Coke is a good reducing agent in blast furnace. So coke को जैसे अंदर डालेंगे, coke does not mean the thumbs up coke. This means carbon in the form of coke. What is coke? Coke is purest form of carbon, means all volatile components have been expelled of. अब जो है, you can't use coke is also available as coke balls या briquettes मिलते हैं, but coke से आप तंदूरी चिकन पनीर नहीं बना सकते. So much will be the heat, it will burn out the chicken. You can't do a barbecue with coke. You need much more lower temperature.
You said like the equation they give and blue and extract will only come. But they've given us some other metals also in the text. So will they ask for equations?
What I have said, you stick to that. If that type of question comes, then there will be question in parliament. My child had a trauma. Okay.
Because
in our days it used to be, now no.
Because in copper, the CuCO3 oxidation rate is given in text, but it came in our exam.
Your exam is not set by CBSE. Your exam is set by your school. There I cannot guarantee anything. Your exam to can put up a question from R.D. Sharma also. That does not mean your exam, if I have fought with my wife last night, so whom do I take my anger on? The lovely little kiddos in front of me. Take a book from 2015 R.D. Sharma and put a question from there. That is a different question. है ना? Your school may also give a 1 mark question in maths, which is actually a 3 mark question with 4 options given to you. I will say, idiot, don't solve that, because no matter if you solve it correct, also you're going to get how much? 1. So I find 1 or 2 schools only who does paper. In fact, the Gulf schools, the schools in Gulf, the CBSE schools in Gulf, they actually design the paper in very nice manner. I've seen, means I've taught their 10th graders, I've taught their 8th, 9th graders, their questioning pattern, especially the first 20 questions in maths, they do it in such a nice manner, which is exactly 1 minute. There you should not complain.
Now the teachers are not making it for the last.
Oh, it goes outside.
No, like the organization.
Fine. So though your school paper, I can't guarantee. School though depends upon what it, sometimes typically in his school in Cambridge, what they have not taught also they give it. So for example, in Cambridge, you know how a question comes. The question will be 5 parts always, not one question. It will have 7, 9 marks. There will be something from metal and non-metal, same thing continued to acid bases, something from carbon and its compound, same story. Now the school has not taught carbon and its compounds so far, and metal and non-metal, but has put that question on half yearly. They don't even take the time to edit, because if you edit, you have to type it again. That's hard work. Who does that? So they pasted the entire question, but the entire question is valid when the entire syllabus is taught. Syllabus ही नहीं पढ़ाया तो वो क्यों डाला? And another school is Birla Open Mind out here. Birla Open Mind is a champion. In grade 8, they will bring concepts of how electron sharing is happening between. जो काम का चीज़ है वो नहीं पढ़ाएगा, बेकार के 10 चीजें पढ़ाते रहता है. Our own advanced science book. Seriously, you will come with smiling face. Don't worry if you chatify this book properly. But after that, next year same time, that's a different story. So understood, ZnS, heat, same reaction, ZnCO3, ZnO, and ZnO with carbon will give you what? Zn plus CO2. ठीक है, आगे बढ़े. इसके बाद हमारे पास कौन सा आता है? इसके बाद हमारे पास आता है one more. Now this is a case study question. This one you should remember. This is called aluminothermic welding process. Now what is the beauty of this process? This is an in situ process. Means in situ means at the spot you can do it, and at the spot you can create, right? For example, railway tracks. Railway tracks cannot be removed and taken to your workshop. You should be able to go there. It's like the operation theater created at your home. वो चलना पसंद नहीं करते, ट्रैफिक बहुत है ना, आप घर पे ही ऑपरेशन कर दीजिए, तो ये घर पे ऑपरेशन होगा आपका. ठीक है. नाउ ड्यूरिंग दिस प्रोसेस मैंगनीज ऑक्साइड MnO2, get it by heart, ये पूछ लेता है लेकिन ना, this process known as aluminothermic manganese oxide and aluminum. In fact, this manganese oxide reaction is also studied in Cambridge, how this comes. Then it will produce manganese metal in liquid form, give you aluminum oxide, and give you a lot of heat. Right now it is aluminum oxide, my dear, and it will give you a lot of heat. This is one. And our process is that when you actually use, this is manganese will come in liquid form. Fe2O3, this is solid iron, Fe2O3, this is iron 2 oxide, reacts with 2 aluminum in solid, and it produces Fe in liquid form. That is, the iron melts up and produces Al2O3 and heat. This process is known as aluminothermic welding process. Now, can you identify who got oxidized and who got? There's a question out here. चलो देखते हैं. आ जाओ. So 3, let's do this. 3 MnO2 plus 4 Al gives you 3 Mn plus Al2O3 plus heat. ऐसे देखने से ही पता चल जाता है. गंध बच्चा, अच्छा बच्चा हो गया, रिड्यूस हो गया. अच्छा बच्चा, गंध बच्चा हो गया, ये ऑक्सीडाइज हो गया. Addition of oxygen is known as. And if you want to test it, see, when we test it by oxidation state, these coefficients have no role for us. So let's test it by oxidation state. Oxygen is what, beta? -2. 2 of oxygen means this is at -4. So manganese must be at +4. Aluminium out here is in 0 state. Then Mn, it is in 0 state. 3 of oxygen means -6. So this should be +3. Okay, so 1 minute. This is oxygen is -2, aluminium is +3. ठीक है, तो हो गया. +4 has come down to 0. Reduction in oxidation state, reduction. Increase in oxidation state, oxidation. Clear? Shall we try with this one? This one is also easy. Fe2O3 ganda bacha became कौन सा? अरे वो तो बैलेंसिंग है. देखो हमारे को इसके लिए ये कोफिशिएंट से कोई मतलब नहीं है. जब आप ऑक्सीडेशन रिडक्शन देखते हैं ना, आपको एक चीज बता देता हूं. इफ यू आर ट्राइंग टू सी ऑक्सीडेशन रिडक्शन बाय ऑक्सीडेशन स्टेट, ये सब कोई मायने नहीं रखता है. ये सब कोई मायने नहीं रखता है. जस्ट लुक एट द मॉलिक्यूलर फॉर्मूला. आओ फिर से. इसका मॉलिक्यूलर फॉर्मूला क्या है बेटा? MnO2. ऑक्सीजन बैलेंस इज -2. 2 है तो -2 मतलब -4 बैठा हुआ है यहाँ पे. तो यहाँ पे मुझे क्या लिखना चाहिए? या एक्चुअली मुझे लिखना चाहिए -2. ये हो गया हमारा -2. ये -2 ऑक्सीजन, एक ऑक्सीजन के लिए बोल रहा है. -2 फॉर 1 ऑक्सीजन. सो व्हाट इज द टोटल वैल्यू? -4. इसको न्यूट्रल करना है तो मैंगनीज क्या रूप में आना पड़ेगा? +4. यह समझ में आया बेटा? ये अकेला ही है तो ये न्यूट्रल ही है 0. अब यहाँ पे आ जाओ, ये अकेला है, न्यूट्रल है 0. यहाँ पे ऑक्सीजन इज -2. -2 पे 3 ऑक्सीजन मतलब -6. -6 को अगर 2 ऑक्सीजन शेयर करेगा तो कितना लेगा? +3 +3 +3 +3 बैलेंस एंड दिस बिकम. अब आप देखो +4 became 0, reduction in oxidation state, and 0 became +3. So who is the oxidizing agent? The one who caused oxidation. तो किसका ऑक्सीडेशन हुआ है? ऑक्सीडेशन हुआ है एल्यूमिनियम का. So oxidizing agent is MnO2. And who is the reducing agent? Aluminium is the reducing agent. तो एल्यूमिनोथर्मिक प्रोसेस में एक और सवाल आपको पूछ सकता है, और वो सवाल ये हो सकता है कि who is the reducing agent and who is the oxidizing agent? Oxidizing, इसका reduction हुआ है. See, end of the day you want this product to come out, so you have reduced it. So aluminium is used as a reducing agent. ठीक है ना? Same here also, aluminium is used as a reducing agent. Clear? Then we go to the next one, that is top one. In this, potassium qualifies, sodium qualifies, so we will go for sodium. So again we will set up what? Electrolytic tank. So we have taken an electrolytic tank. Oh, here they are showing this is refining. ये इसमें just छोटा वाला दिखाया है. So we will use sodium chloride. Sodium chloride will be taken in what form? Molten form. Aqueous नहीं चाहिए. Aqueous देने से OH minus रिलीज कर देगा. Aqueous वाला कहाँ यूज करता है? Chloralkali process में यूज करते हैं. Remember, aqueous sodium chloride means that will be used in chloralkali process. ठीक है? In that chloralkali process, aqueous means first water will split. H, OH plus, OH minus and O. So you will get NaOH, chlorine and hydrogen. 3 things. This is not that. Here we will use molten. अच्छा, what is called brine? Concentrated solution. ये brine नहीं है, ये molten है. And one more thing comes up. Does salts conduct electricity? No, they conduct electricity only in molten and aqueous form. ये molten form में आ गया. So the story becomes same. Sodium is the one that you are interested in. Sodium is plus. So sodium should travel to minus. So if you see at cathode, at anode, always, let's see the reaction. Sodium plus gains an electron and forms what? Sodium. Gain of electron. Gain of electron is known as what? Rig. Gain of electron. So this must be reduction. This is my reduction reaction. Gain of electron. Then we will have Cl minus. Where did you get this electron? The chlorine actually lost this. The chlorine, the chlorine actually lost this electron. Cl minus. This is oxidation. OIL is loss in of electron. So this process is known as my oxidation. Further, plus has become, plus means +1, +1 to 0, reduction in oxidation number. So this is also reduction. -1 to 0, -1 to 0. So this is oxidation. And I told you oxidation always happens at anode. ये देखो reaction में at anode लिखा हुआ है. So this is a at anode. And this will be at cathode. Clear? Any doubt? Don't use the word aqueous. Aqueous use करोगे तो राम और श्याम के साथ सोनू और मोनू भी आ जाएगा, H+ and OH-. Whole thing goes for a toss. It is only molten aluminum. And use your common sense always. Metal has to travel to the negative. For that, metal has to become metal positive. So it has to lose electron. And losing an electron means oxidation. और मेटल किसके तरफ जाता है? नेगेटिव. तो उसको नेगेटिव टर्मिनल पे कनेक्ट कर दो. और इस साइड पे ऑक्सीडेशन हो रहा है, तो इसका नाम एनोड हो गया. और कुछ नहीं याद आया तो आंध्र प्रदेश, डोंट पैनिक. उसके बाद आ गया रिफाइनिंग ऑफ कॉपर, एंड देन कम्स कोरोशन. ये नहीं पढ़ाऊंगा. तो ये है इसमें. व्हाट इज कोरोशन? हाई कॉस्ट in the economy. You know, Eiffel Tower's maintenance is so costly. Every year, tons and tons of paint has to be put so that our friends can go and click pictures below it and put it on Instagram. And corrosion is a big dent in the economy. So types of corrosion prevention, basic case galvanization ho gaya. Then you can coat it with magnesium paint. The only thing is corrosion will happen only when you have two enemies with you. This is the last topic. So as copper reacts with moist copper. See, copper has two type of things. Copper is not called copper rust. You spoke about iron. Copper is a very typical thing. Copper will react with carbon dioxide, moisture, that is a combination of oxygen and water vapor. So copper will form two things. One is known as copper carbonate and one is copper oxide. Copper carbonate and oxide together will give you that. Copper oxide is always black in color and copper carbonate is greenish. That's why I tell you, whenever you see these AC pipes, watch them clearly. You will find a greenish black coat on that. That greenish black coat is not. This was there in grade 8, if you remember. Copper's corrosion is a mixture of two: copper hydroxide and copper carbonate. Understood? And for corrosion to happen, you need two enemies: oxygen and moisture. Moisture is in the form of water. Any one you can cut off, your corrosion will not happen. So one of the easiest ways are painting. What does painting do? Painting creates a layer, barrier. This is called barrier method. You're creating a barrier between oxygen and this. Another is galvanization. But in galvanization, again the same story. Why are you galvanizing with zinc when zinc is higher in the reactivity series? Because zinc once forms oxide, does not last. Similarly, same is with aluminum oxide and same is with magnesium oxide. Ships are coated with magnesium. Those ships move in marine environment, but still they are coated with magnesium. Magnesium is highly reactive. बच्चे को बुखार हुआ है, बेटा कमीज उतार के ना बाइक चलाया करो और ठंड में. सर और ज्यादा ठंड लगेगा. नहीं, उस पे जो लेयर बन जाएगा विंड का, वो और आगे कुछ भी. ठीक है? So I think these all case study आएगा तो unless जो सब इंट्रोडक्शन कर एक खत्म कर लेते हैं. So these are all chinumunu questions, prevention of corrosion, all these. And pure gold, you know, is 24 karat, but 24 karat we cannot manufacture ornaments. It will not hold. Therefore, we always make it in 22 karat.
Sir, an alloy is with virtually any metal you put, it's called amalgam. Sir, the name does not change.
Amalgamation is also a name of mixing up. Like we say, our first year students and our second year students will have an amalgamation session. Intermixing.
So no matter what the metal, the alloy will always be called amalgam.
Amalgamation is a process. It's not, amalgam is not the name. It's like a process. Amalgamated. Chalo. और इसमें कुछ नहीं है. Rest. Now we will go our question sessions. Okay. Some basic idea. Statistics. We will not do mathematics now. I'm not going to do any formulas and all.